Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a topic regarding the loss of air due to bend in a pipe and the loss of air due to various fitting in a pipe. So last few lectures, we are discussing regarding the loss of head or the loss of energy when the fluid is flowing through a closed pipe. So already we have discussed regarding the loss of energy. That loss of energy takes place due to the mainly two regions are there. One is major loss, another one is minor loss. So we already have discussed regarding the major loss part, and minor loss also we are discussing right now. So major loss used to happen due to the mainly friction in the pipe. This is the loss. Okay, loss of energy we can write. So loss of energy or loss of head, we can tell the same thing, both are same. So now this major loss used to happen, we have already discussed regarding the friction, and to identify this major loss we have followed two methods. One is Chezy's method or Chezy's formula, another one is Darcy-Weber's equation or formula. By that we can able to calculate the major loss in the pipe flow, and this minor loss is having like a few cases are there or few conditions are there due to that minor loss used to occurs. So this minor loss used to happen due to the sudden contraction, sudden expansion in the pipe, and obstruction in the pipe, and exist and entry in the pipe, and we can say due to the bend in the pipe and fitting in the pipe. So these are the cases are coming under the minor loss. So right now we are discussing about the minor losses, minor loss of or loss of energy or loss of head due to bend in a pipe. So let consider a pipe. Suppose this is the pipe is there, and through the pipe the fluid is flowing. Okay, and suppose this is the liquid or the fluid which is flowing with a velocity of v, and the liquid or the fluid which is flowing through this pipe, okay, will have a velocity like if up to what distance we can say the pipe is continuous, we can say the velocity will be like it will flows all over the boundary or surface of the pipe. Okay, suppose this is the flow of this liquid which is flowing through this. Okay, now before bending you can say that before up to bending the pipes are covering all the surface area of this pipe, okay, in the flow. But when this pipe starts bending in this, so the fluid will be like it will be flow like it won't cover all the surface of the pipe, and suddenly the flow also started separating from each other. That means it will come like this, then again it will strike, then it will come back like this. So then it will go with a flow. So that means there will be a gap, or you can say there is a gap between the liquid or the fluid which is flowing and the surface of this pipe. Okay, and the fluid which is coming, again it will be strike like this, it will be come directly from here to here because due to the sudden bend in this pipe, so it will become like this. Then again it will be after striking here in this surface of the pipe, then again it will become back like this. Okay, then so here you can see due to this disturbance of the pipe, okay, there is a turbulence in the fluid created. Okay, there is a turbulence in the fluid created. So here I can write the turbulence occurred here, or we can say one more thing, that there is no chance of smooth flow in the fluid. So due to it is not a smooth flow, I can say this is a turbulence is created in the fluid flow. And apart from this, during this flow separation, because the flow is separated, as you can see nowadays in up to here we can say all the velocities are constant or uniform flow is there in this up to this, and before after bending it is not like that. So meanwhile when this liquid will be flows over this one, at this junction, at this point, few eddies formations will be occurs. Okay, few eddy formations will be occurred here at this point due to the flow separation from the boundary layer and the disturbance in the flow. So the disturbance in the flow means the disturbance in the velocity. Okay, because I already told you that the velocity of v equal to the velocity of the fluid which is flowing through this pipe, and suddenly there is a change in the pipe construction, and due to the bend in the pipe, the velocity also disturbed here, and due to that, you can say there is a loss of energy happened due to this eddy formation, due to the velocity changed here. So what we can write here, or what we can say, this eddies formations are there. Due to this eddy formations, loss of energy takes place. Loss of energy takes place. So the loss of energy we can write, though it is due to the bend, we can say. Now, due to this, due to bend in the pipe, what are the points are what are the things are affecting in the fluid flow? We can see there is a change in fluid flow, or you can say there is a change in fluid direction. Change in flow direction, we can write. There is a change in flow direction. That means up to here we have a x-axis direction, or x direction the fluid is flowing, and suddenly it is changed its direction. The flow direction changed here, and this one, second one, what we can write? Now there is a turbulence or separation is created. I can write there is a turbulence and separation of flow. Separation of flow occurred here. So that we can see from this point, as suppose if I draw a center line of this fluid, this is the suppose central line or center axis of this pipe or the fluid. Yeah? So now how the fluid changed its direction, it's coming like this. So here also like it is coming. Okay, after that, sometimes it will be as usual flow normal. Okay, now next what we can say, now the pressure also, what is the pressure was there at this point. So if you after changing its direction and this flow and the velocity changed, so here also we'll get a pressure difference is different. So that means there is a pressure gradient was occurred here, or the pressure difference was identified there. So there is a pressure difference will be there in this point. So these are the some points which are affected due to the loss of head due to the bend in the pipe. Okay, so now we can write that is the loss of head or the loss of energy in any bend on the pipe. Okay, the velocity of flow, changes due to the separation of the flow from the boundary, and the eddy formation takes place, and due to that the energy loss identified. And for that, what we can write, that velocity or the loss of head due to pipe bend, we can write in terms of expression, HB equal to, I can write K V square by 2G. So what is K, what is V? Now V already we know this one about the velocity of the fluid flow or velocity of the flow, and here K equal to the coefficient of bend. Here we can write this K equal to coefficient of, this is coefficient of bend. Okay, and HB equal to, as I told you, the loss of head due to the bend in the pipe. Now this coefficient of bend K, that will depend actually many factors. Now we can see the K coefficient of bend, this is the bending part is there. So this, due to this bend or this K value will depend many factors here. So the K will depend actually, I can write few points here. That means what is the angle of bend? What is the angle of bend? What is the angle of this bend? That first point. So that one we can write, this is angle of bend. And second, what I can write about this curve, like this is one diameter was there, and what radius this was, this curvature was formed, or this curve was formed here. So that we can write what? Now the radius of curvature of the bend. This one we can write radius of curvature. Okay, and next is what I can write, what about the diameter of this pipe? Okay, what is the diameter of this pipe, and this point, like what is the diameter, similar diameter is there or not, or diameter small or large is there. So that also one factor in this K, or coefficient of bend. So diameter pipe also required. Then only we can decide that based on this diameter how much bending required for this. So that also one parameter. Along with that also we can say that flow velocity V, that also one parameter for this K. So this is all about this loss of head due to the bend in the pipe. And similarly, while discussing the next point, this is one, and the next parameter is the loss of head due to various fitting in a pipe. So as I told you that these are the one conditions in the minor losses, or we can say these are the one cases in the minor losses. So this loss of head due to various fitting. Now you can see in our pipeline we have number of fittings are there, either in terms of valves we can say, okay, or already bend I have shown you. So suppose this kind of fittings will be there, and there will be elbow fittings will be there, or valve fittings will be there. So even elbow will become under this bend, okay. So here also some kind of valves we can connect here, and like inlet valve and outlet valve, and sometimes couplings will be also fitting. So what are the fittings you can say? Now one is valve fittings, and already number of joints due to this elbow fittings, T fittings will be there in that, so that may come under the bend in the pipe. So here we can say due to the couplings, also coupling also coming under various fittings. So due to this number of valves and couplings which are fitted in the pipe, for that also there will be loss of head. So this loss of head is nothing but the loss of energy. So energy is directly related to this velocity of the flow. So that's why if you see all these equations are associated with this velocity, okay, because it's directly related to the kinetic energy. So there is some disturbance in the flow, or that means there is disturbance in the velocity. That's why we are calling as a loss of head or loss of energy. So for this also we can write H, here various fitting is there, so we can write HF. So here we can write kV square by 2G, because these both are similar kind of things. These both are similar things, only here bending is there due to the bend, and this bend is nothing but that coefficient of bend K. And here if you see, this is here coefficient of pipe fitting, we can say. Here it is slightly different. This is coefficient of pipe fitting. There it was bend, and here it you can say the pipe fitting is there. Okay, and V is the velocity of a flow, that we know, velocity of flow. So this is all about the loss of head or loss of energy due to bend in pipe and due to various fitting in a pipe. I hope you understand this concept. Still, if you are having any kind of query, doubt regarding this, you can give a comment on the comment box. Thank you all.